there's a little bit of fun to be had, depending on how you consider fun. This is going to be a Miro session, so I'm actually going to post the Miro board link in the chat there right now. And if you click on that link, hopefully you won't be selling all your privacy secrets. You'll just go into the Miro and you'll be able to see what I can see. And then I'm going to kind of drag you around my presentation, Pied Piper style. So you can follow me around, and you can also wander off and see other parts of the presentation if you want to. So we're going to try and test this as an alternative to PowerPoint for doing future workshops. Presenting today is me, Alan Burden. Hello, I'm a postdoc in Program 3 at the ACC. Most people will know me by now. If you don't, then you might not have seen some of the other seminars that we've done. I am co-presenting today with Fikre Gebremeskel, who is a PhD student in Program 3, also at UTS, with the supervisor of Matthias Gertler, who was also going to co-present today. Matthias is away and sends his apologies. And part of this research today is actually one of Matthias's papers. So if everybody is now in the Miro and following along, you can either follow in the Miro. I'm also broadcasting what I can see. It's been more interactive if you're doing this on the web yourself. And I'll start the presentation now. Hopefully you can all be able to see what I can see once you join the presentation. Okay, so this seminar is about pilot work that we've done so far in implementing cobotics under socio-technical systems, which is the basis of our research in Program 3. A quick reminder about what we do. We have 3 different projects, which are PhDs, PhD based. So project 3.1 is human factors in collaborative design, looking very much at human-centered design, user experience, and the outcomes of robotics being in industry areas where humans have traditionally done that work. Project 3.2 is socio-technical design factors, which looks at the holistic elements that make up the human and robotic interaction and collaboration that we are researching, and tries to make sense of how all those elements work together. And this will be a key part of today's presentation. Project 3.3 is AR and VR factors, very much as a peripheral and very supportive field of research and industry that feeds into robotics and other industry 4.0 and also 5.0 elements as well. And my research kind of holistically covers all 3 of these different separate projects and makes outcomes from that. The 4 areas that we generally concern ourselves with socio-technical, depending on which technology it is. In cobotics, we look at the cobot itself, or the robot as it's used to be. So the cobot itself, the interrelationship between the cobot and the human operator, and then also the effects of the product that's being made or being worked upon, and also the workplace, so the effect of the environment that needs to be designed around that. And all these elements come together to make up socio-technical. So today's seminar, we're going to do a quick warm-up exercise here in Miro it'll probably take about 1.5 minutes. And then we're going to do a mini workshop, which will be just answering some of the questions that Matthias and I had earlier this year when the CIRP paper was being written, and thought this might be a good opportunity to have a captive audience to follow this. And Fikre will then present factors of implementing cobotics, which is the essence of his PhD thesis that he's currently starting. I will look at the case study for implementing cobotics, which is early stages of user experience research, and also human and robotic interaction queries feeding into how you would design for systems like that. And then we'll end up with a summary and some questions. So this is the link. Hopefully everybody has the link right now. I don't believe that Miro will work that well with iPhones. I tried it yesterday. It didn't seem to work well. I'm assuming tablets might be the same, but this is all just a big learning experience today. So as a quick warm-up, we're just going to do what is your ideal holiday destination. This works quite simply. Hopefully everybody out there will be able to grab one of these voting dots now. Oh, maybe. Yes. Oh, yes, everyone's doing it. It's amazing. Thank you. I thought this will take about 30 seconds to get through this. This will give us a good indicator as to what our audience is like. And I'll tailor the seminar accordingly. Someone's sitting really on the fence there in the middle. Excellent. That's a widespread. I thought that we'd have a lot of maybe tropical adventurous, but living in Australia, some people are yearning for the winter wonderland as well. Excellent. There's a real outlier out here as well. Okay, excellent. We'll move on to the next one. Thank you for that. I'll do it this way. There we go. So this is a little bit bigger. And we're going to ask a question about what is your first job? I think everybody's always had kind of a dire, very first teenager job or something otherwise. And what is one lesson that you have learned from that job? And I'll give you 2 minutes to do this. That's some really interesting ones here. I think the best part of this is that it's anonymous, so I have no idea and we'll never know unless we're tracking people. Actually, it's not fully anonymous. There are some people here who are logged in as themselves. Okay, another minute to go. Some great ones here. Drivers getting money tips, good tips. Someone did factory work and the lesson was go to uni. Cashier at a bakery, waking up early. Register department at Target. Folding fitted sheets is hard. That's a life skill, definitely. IT help desk. Phone call warranty claims are painful. Picture framer, keep your fingers away from the saw, the bench saw. That's a good one. Okay, this is excellent. Okay, that's time. Thank you for that. That's excellent. It gives you a good insight into humble beginnings from everybody. Okay, so that was the warm up. And so now we're going to go into the questions for the actual mini workshop, as we're calling this. So these are going to be two different activities. There's going to be one question for the first activity, which is how would you describe your exposure to cobots? So this is about your experience to cobots, whether you've seen a lot of them, whether you actually use a lot of them, or whether you've just barely heard the word at all. And the second activity will follow for two questions, and it is what are the advantages of using a cobot at your work, and what do you think are the challenges are with implementing a cobot? Okay, so here's the first one. So this is similar to the axis separation work warm-up that we did before, but this time you put it into a zone. So top quadrant left or right, or bottom quadrant left or right, depending on how you feel about that. So we have top left, I frequently interact with a cobot. Top right, we have a cobot at my workplace, but this means that you may or may not have ever used one. Bottom left, unlikely to use one anytime soon. And bottom right is occasionally I use a cobot. I think originally I must have put these out clockwise. I'll give everyone about another 30 seconds or so to think about this one. I made this deliberately nefarious in its wording. I want to see. Okay, I think that's good. That's everyone. So I was gonna make a big assumption and say that a lot of us would be up in this corner or maybe this corner here, that we actually see cobots, but we don't really use one that often. And being at the Cobotics Center, I imagine that this data is terribly skewed towards this quadrant in the top left here. Okay, excellent. So next activity and 2 questions. This one requires a little bit more writing, but the idea is to be punchy here. So what are the advantages of using a cobot at your work? Is the first question, and just fill in on one of these green post-it notes. There's plenty of notes because I had no idea how many people we would have, but feel free to copy a note if you want to do more than one. And then the second question, what do you think the biggest challenge is with implementing a cobot at your workplace? And I was going to give about 3 minutes for this, but I'll see how people are going with typing. So about 2.5 minutes, I'd say, starting from now. Okay, 1 more minute to go. Okay, 15 seconds. Okay, I'd say that's time. Okay, so rather than discuss these here, I'm going to collate and have a look through these while Fikra presents his next section, and then we'll discuss these results and how they correlate with the work done for the CIRP paper at the end of Fikra's section 4. So Fikra will now take over and present this next bit of work. Fikra, are you there?
Yes, yes, I am.
Okay. All yours.
Thank you, Al, for giving me the chance. So most of them seems they have somehow know-how about cobot. So I will start by briefly introducing about cobot or collaborative robot. You can hear me, right? Okay. Cobot or collaborative robot are robots which are collaborative, or they are types of robot who can they are designed to work safely and effectively alongside human in a shared workspace or in collaborative environment. So typically cobots are come with made up of mechanical components, electrical components, sensors, and some software programming. And when you add some tasks using the end effector and some workpiece, it become cobot system. And when we combine cobot system with human and other social aspects, it becomes cobot workplace. So these types, there are different types of human and robot interaction modes from traditional, and they become more latest. The types of interaction are collaboration, cooperation, coexistence, and cell. Cell is like the traditional type of robot. Now they become more latest and more collaborative robot. They have some differences. Collaboration robot, in terms of interaction, the task human and robot work simultaneously on a task. And as you can see from the circles in the picture, they have common workspace, and the physical contact is here desired in the collaboration type of interaction. In the cooperation, they have common workspace, but the tasks are sequentially. And coexistence, as you can see from the circles, they don't have common space, common working space, but they exist near to each other. And the contact here, it is possible but not recommended, the physical contact. And on the robot cell, the physical contact is it is hazardous, and they have separated work. Usually they use fencing to separate the human and the cobot. So this time researchers are focusing on the collaboration part. They are trying to make it more collaborative. So our research focuses on the collaboration part, so to make more collaborative from the socio-technical perspective aspect. So to summarize this slide, or in summary, cobots are type of robots that can work safely with human, alongside human, in a collaborative environment. So in the next slide, I will explain a bit about program 3, how we are planning to implement the socio-technical cobot system into the workplace. So firstly, we analyze the existing workplace, and then we understand the complex interdependencies between different domains in the collaborative environment. And then we design the socio-technical cobot workplace. After that, we try to simulate this collaborative workplace using alternative cobot setup using AR and VR, which is related with project 3 in the program 3. And finally, we plan to implement cobot workplace in real industrial application. So my research pertains to the two phases: understanding the complex interdependencies and design the socio-technical workplace, which is will present in the next slide. My research, the aim of my research is to support manufacturing companies in adopting cobots or collaborative robots into their workplace by analyzing the interdependence among different factors within the various domains in the collaborative environment. There are different domains like cobot domain, human, workspace, and product domain, and production process or manufacturing environment domain. So in summary, the aim of the research is to support manufacturing companies in adopting cobot, and our focus is in understanding the interdependencies among the different factors. So on the next slide, to achieve the aim of this, aim, we have 4 main specific objectives. The first one is to identify the factors, the different factors inside the collaborative environment. We identify the factors from literature review and from company survey, or by making interview with different representatives from the companies. And after identify the factors, we map the interdependencies between them using different tools. Then after we map the interdependencies, we develop a guideline on how to adopt the cobot or socio-technical cobot system into the workplace. The guidelines, firstly, they are documented, and by collaborating with Project 3, in the program, so we can make the guidelines interactive. And then finally, to evaluate the guidelines in experiment in lab settings and in real industrial application. So in summary, we identify the factors, and then we, from previous slide, sorry, so in summary, we identify factors and map the interdependencies and then evaluate in real application and in the lab setting. Currently, we are on the identify factor phase, which is we are conducting literature review, which will be in the next slide. So we are in literature review part, or collecting the different factors that are happening in the, or that are challenge for cobot adoption. So we are using Scopus database and using the search keywords, cobots or its synonyms, and adoption or its synonyms, and manufacturing. And about the string, it is a bit long story, which I am not going to present here, but we using this search keywords based specifically focusing on title, abstract, and keywords of articles. We have identified total 235 journal documents. Then we screening them from the title and abstract. Then they become almost half of them was screened. Now we are on the identifying the eligible documents phase. So far, we have identified and analyzed 13 journal documents. Totally, the document type, that 110 document type are, most of them were from the engineering subject areas and computer science and also social science. And by year, from most of them from 2019 to 2020. So the result of the 13 documents, we are including the closely related and partially related documents, and the loosely and non-related, we are screening them. So on the next slide, I will a bit explain about the results gathered so far. So here, these are some factors we identified from the literature. We will also gather from companies, as I explained before. So we are categorizing the factors into human domain, cobot domain, workspace, product, and manufacturing process domain. Also, the factors could be challenges or barriers. Also, they could be enablers. They could be attributes of the domains, or it could be kind of requirements. So we categorize them and we analyze the interdependence between each factors and the domains. So in the next slide, I will show you example of the mapping the interdependencies between the domains, but based on the attributes of the domains. This research was done with Matthias and other teammates from Program 3, which in the last year. So here they make the interdependence between different attributes, and they identify if the dependency was strong, weak, or no link. So if you see, for example, the workplace attributes from the workplace has high connectivity with other attributes with other domains. For example, if you see the scope of application, it has high connectivity with other attributes. From the cobot attributes, the speed attribute has high connectivity with other attributes. So this is how to make the link, to identify the link between different attributes. So it will help you. It will help one to identify the links, the strong links, and to make some research or some solve some challenges. The result of this this publication will be published. After the publication, we will put the link on the ACC website so you can see the detail of the paper. So in summary, this is my last slide. So in summary, I have briefly introduced about cobot and different cobot system, different cobot collaboration modus, and then I briefly explain about the Program 3 plan, then my research specifically to my PhD research and status and current result. And also from the discussion part, you have mentioned some of the challenges. Some of the challenges are aligned with the factors that are identified most of them. They are aligned with the factors that are identified from the literature review. And some of them, they are a bit different. That's why we are trying to collect the data, not only from the literature, but also from the company. Regarding the discussion, my teammate Alan will a bit discuss about it, and he will continue to he will a bit discuss about the total program tree and specifically with the AR and VR factors. So I will hand over the presentation to my teammate Al.
Thanks, Fikre. That was excellent. Thank you so much. So, as Fikre did indeed point out, there are many similarities between this domain matrix from the CIRP paper, which is in pre-publication. So we'll have a DOI number pretty soon to share with everybody. One thing that I've noticed that consistently comes up when we quiz people is the idea of fear. So as a negative, and it's something which I don't think is fully captured within this particular type of domain matrix, is how are you going to handle this element of resistance amongst employees when you introduce a cobot into their system, and it's just good old-fashioned education in order to get the message across that this is not going to end your job immediately. We've got several commonalities between this matrix. So accuracy, safety, being able to delegate simpler work whilst the human is allocated to more decision-based tasks, increase an enthusiasm for robotics in general, and doing applicable research, filling in skill gaps as well. And of course, this will be upskilling and reskilling for many employees when a cobot comes into the system. And the big challenges, of course, are things like the entry price, is that the prohibitive cost of cobotics, even though cobots themselves actually decreasing slowly in price from manufacturing themselves. A lack of know-how in the system, safety and technical barriers, translating complex work routines into something that a robot has to do. These all require a fair amount of expertise, but also resource to get working. So I'm just keeping an eye on the time. I've got 10 minutes to go. So I'll present for another 5 minutes. If you're not following me at the moment, you can hit on in your screen, you'll be able to see return to Alan, and you should be able to follow me on the slides still, because everybody tends to wander off in no man's land on Miro. So one of the elements that Fikre was talking about was kind of contextual analysis at the beginning, and human-based analysis to find out what these tasks are that could actually be assisted by cobotics. So these images, I'm sure everybody that's a regular attender has seen now. It's the gasket room task at B&R Enclosures in Heathwood in Queensland. And this is typically an intensive manual task that requires quick decision making and has periods of kind of meditative slow procedure, followed by intense decision making and intense activity that tends to pressure the user, the single user, and has been traditionally referred to as too much work for one person and too little work for two people. So it's an ideal scenario for introducing a cobot. I like these two diagrams. The one on the left, it shows the difference between design thinking, user-centered design, and human-centered design. I've deliberately left those in the acronyms there. Design thinking is a word that's is a phrase that's often used and as an umbrella phrase to cover every other element of kind of design thinking. So user-centered design and human-centered design, human robot interaction design tend to fall under this big design thinking umbrella. But I like this diagram because it generally shows that design thinking actually involves a lot of other elements as well, which doesn't fully align with user-centered design, which is quite targeted towards a particular type of user, and human-centered design, which is targeted towards all humans as users. I'd say in general in this program, we aim towards human-centered design because we are not just looking at one particular user. We are preparing cobots for a workplace that will appeal to a wider range of users. And ideally, if it can be intuitive that you can send a single human into an interactive system with a cobot, that would be far better than actually targeting a particular user for each one. The diagram on the right-hand side is a particularly nice one from a paper by Pratti et al. I'll put the link there at the bottom. And this shows a typical UX design cycle that's been heavily adapted to include and to map for robotic interaction, so human robotic interaction, and then by extension human robotic collaboration as well. So starting at the 12 o'clock of the clock face, you've got requirement gathering using typically multidisciplinary teams, because you get to see many different perspectives. Performing user analysis, which often involves interviews, surveys, workshops, good old-fashioned observation in the wild, watching people in situ doing their job, and ethnographies, learning how they work and why they work and the experience that they have. An analysis of the activities, which buries down into the smaller, more granular levels of the tasks that they're doing, and then finding and abstracting this through interaction visualization. So typically visualizations, of which I've got an example in a few slides, which can often uncover things that you might not see if you just had a list on a page, for example, or if you're looking at a single matrix. We are using matrix extensively in this program. User task matrix have been particularly useful, and this study by Pratti has provided a very good foundation or framework to do our own work with. And then coming up with experience maps as well, which is another area of visualization that works quite well. All these things from requirement gathering can feed into an interface design and prototyping, which is a kind of very typical design cycle that you see in most design research fields and topics, going through iterations of prototyping and then testing. So testing in this case is generally user assessment testing or user testing, and there are several within user experience design which kind of uncover this. So I'm really running out of time, but I wanted to kind of go through this matrix. I presented in the last seminar. I didn't quite have enough time to follow through with this, but this is the matrix that we've been using with the gasket room study, which has been taken by Pratti and altered ever so slightly with a few different variables that we were looking for. Just taking one of these as an example, if we go for, let's say, number 3, maintain and replace the gasket nozzle. This is a particular task within the gasket room, which doesn't happen very often, but periodically throughout the day it has to happen. And so this is a smaller action performed by the human that needs to be tracked because it requires you to interact with a machine within that space. So here we're looking at 4 different areas. We're looking at task mapping, the interactions, the information that we're gathering from that, which is essentially communications, and also the context. So going to tasks, we have a general overarching title for this task, which kind of gathers it and names it succinctly. And then we have a description of the task, and this can be multi-level. So for number 3, the task is maintain and replace the gasket nozzle, but this actually involves entering the safety cell, removing and replacing the gasket nozzles, and then testing the nozzle after it's been inserted. The interactions themselves, you've got the interaction elements. So these are the actors that are identified within the space. So you can kind of compare between operators that are in there, whether they have interaction using that task, for that task using, for example, a computer, the gasket machine, the dosing element of it, the gasket control panel, the shuttle table, the gasket machine, the mixing element, or other elements that are in the room, other tools such as the pallet jack or the trolley jack that was in there, or the workbench or trestle table. And then we give it a general duration for the amount of time that it's spent in this task. And this has bearings later on when we start developing interaction elements and user experience and user interaction components for VR or AR, for example. In communications, we have operator to machine, and machine to operator, which is feedback. So generally it will be one of these two or both of them in typically. So the operator is asking the machine something or telling it to perform, and then the machine is giving the operator a feedback that it is doing that task, but it's a flashing light, which is typical in most manufacturing industries. Operator to operator rarely happens in this space. And you've got other communication elements there, like difficulties and critical situations and what that person will do to overcome them in their workspace. Working conditions captures elements that are interesting, such as noise, difficulty, handling, dust and grease and gloves, and this you can vary accordingly. I think we're coming up to on time. I might have to do another seminar about this topic on its own, I feel. This is the topic, the domain matrix actually visualized, and you can actually load up a lot of information on a very abstract diagram such as this, and you can also strip it back. And the best part about this is that you can kind of, when you see it visualized in this manner, you can actually see busy areas where things you have to make a lot of decisions. So where there's a kind of a change of an arrow or different direction of an arrow, that means a bit of multitasking is generally going on in that space. And this kind of highlights areas where a cobot could be useful in helping and assisting. And this is my last slide, which is actually just showing some of the VR simulation and cobot integration. And I've given other seminars about this in the past, and feel free to look those up on the Cobotic Center website and YouTube channel. And that's the end. Ran over time, shame, but hello. Is there any questions from anybody? In the 2 minutes?
Fantastic, Alan Fikra, thank you so much. That was really great. Let's see, we might have we've got 2 minutes for any questions that anyone might have. I'm just looking in the audience. I think one of the questions that we all might have is, what's the immediate next step for the research? But I guess that's quite a big question and something that we'll have to dedicate another seminar to. Perhaps so. I think the next stage for now is to start making prototypes and testing them. So we're going to start making physical prototypes for a cobot in situ. So we're going to do that at the Arm Hub, we hope, and then we will start testing it in the Arm Hub before we take it back into the factory. Excellent. Right. Did anyone else have any questions? Let me just check the chat. No. Well, you both covered a lot of information, and yeah. If people do have questions, I think they know where to reach either of you. We can be, your all contact details are on the website for the center, and yeah, I'm sure you'll be very happy to answer any questions that people might have. Absolutely. Okay. Well, thank you. Thanks for attending, everybody. Thank you both so much. That was really awesome. Very proud of you. If anybody does actually have any feedback as to whether Miro was a raging success or an abject disaster, please let us know, because I think it's a very good way to do workshops. I've done a few Miro workshops like this before, and they do work well, but they require a lot of preparation. So this was just great. Thank you, Mark. Yeah, Mark's put some comments that he's like the Miro. So I think we'll continue trying to use it because it's a good way to get feedback from the audience. Yeah, very engaging, interactive. Awesome work. Thank you. Thank you, everybody. And thank you, Fikra. Bye, everyone.
Thank you.
Goodbye. Thank you.